sessions will be recorded. I'll be uploading it in like 1 hour after the completion of it because it takes time to export the video and stuff. So after 1 hour, it will be uploaded to a Google Drive for now. I am building a product around this to basically help me manage my code better. So mostly it should be done in next couple of weeks. And then I'll be sharing another link on which you can access the lifetime content and stuff. So I'm planning a few really interesting sessions and basically not just restrict learning to this 2 months, but more basically spanning like 5, 6 years, but basically till the time I'm actually continuing it. Like basically random talks from the experts of industry, not being part of this cohort, but it will be some sort of separate sessions that we might have over weekends and all. I'm just planning it. I'm just preparing the list of guests if I can bring any. Yeah, a lot of things are planned there. Chalo, it's four. Let's jump in. Yeah, so how many people have joined in? Arre, 23. Still a good number. Nice. Chalo. Guys, basically, thank you all for actually enrolling into this cohort. I hope you would have a lot of fun learning system design, and specifically not just from the perspective of interview, but in general discussing a lot of really interesting stuff. So before we like jump into the system design part of it, and obviously what I'll be doing is and obviously what we'll all be doing is we'll be jumping right into system design from the first day itself. And but just before we start that, to get the most value out of it, just want to put few things out. Speak up and participate. Don't hesitate to just raise a hand, and I'll basically pull you into the conversation. And if you have any doubts, speak up. If you want to contribute, if you want have something interesting to say, don't worry about it. Just raise a hand and I'll just pull you in. And I'll be using a lot of terms. The course is really intense. So if you stumble upon new terms, go ahead, make a note, do a bit of Google after the class ends or in parallel with your window, and just get a gist. Okay. And if it actually deviates too much, if you want me to explain it, feel free to bug me. Right? No problem there. And in general, it is always a great practice into just making a note of few things that you hear and read about them later. You would have to revise because the course is non-repetitive, which means that a thing that we have discussed, we will never, we will be using it obviously, but those concepts might not be basically might not be covered again. So it is always better to revise because because the course is like a story. Every week, the things that you learn in the first week will be something that you'll be using in the second week. The things you'll learn in the second week, you'll be using it in the third week, and so on and so forth. So in every system design, there will be a point where I'll say, "Arey, remember we use this in the first week, we use this in the second week and stuff." So we will be doing that quite a lot because that is where a very solid foundation of basically building great systems comes from, where you have a very high recall about how you have done something very similar, or you can take inspiration from a very similar system that we have built, or a very similar Lego block that we have learned, and using it at other part. Ask questions. To be really honest, it actually doesn't bug me when someone asks me a question because that is how a lot of you will. Malab, what actually happens is the same question might actually pop up in 5, 6 people's head, but even if one of them speaks up, it basically answers the query of everyone else as well, and it obviously helps us run this discussion better. This is definitely not going to be a monologue, so I want really active participation. So whoever wants to speak up, go ahead and do it. Uh, and if you need one-on-one help, I'm just a message away. Just ping me on Discord or on email anywhere, and I'll get the call set up. So, but you just need to do it a day prior because I have to manage a little bit of time. But the slots are wide open, so don't worry about that. There will not be direct assignments. I'll in in the process of the course, I'll be pointing out few things that you definitely should implement. But obviously, due to time constraint, there won't be any evaluations. But if you do it, if you build things on your own, it will be really fun, right? And you'd have to put in efforts. It's not spoon feeding. It's not that there is a question and I have the answer, there is a question, there is an answer. No, it's not like that. It's about like we understanding that system from end to end, from the perspective of engineering, and basically trying to build a solution around it. And be a little extroverted if you can. No pressure there, but it is always better to speak up and participate. Uh, Share any great article, video on our Discord channel, over our Google group, anywhere you would like. If you come across something interesting, do share it. There have been a lot of great resources which is being shared on a few of our Discord channel. I'm trying to make it active. It is just a new thing for me. I'm actually planning to bring in few TAs who can help in the who can help in basically playing the long game. Acha, coming to that, this is where this is the most critical part of it, that we play the long game. It's not that in this 2 months you will be the master of system design, right? But you'll get a really deep understanding of how real systems are built, not just from interview perspective, but you'd have to continuously evolve yourself. You would have to keep learning things on your own, explore new things, and more importantly, be hands-on. It might take you to complete the course in 4 months, 5 months. I have people from the first cohort who last week completed the course because it was really dense. Right, you will get the gist on how it would be after the first session itself. But in case if you find it a little pacey, you might have to pull up your sock and actually put in self efforts. It's not really that intense, but it is fun because we'll be discussing like a really massive spectrum. So but yeah, definitely if you people from the first cohort, they watch video thrice, well, every single video thrice, because the information density was high, and they were trying to like grasp it. And then I basically toned it down a little bit in the second one, and the second one was like really awesome for me. So I am basically keeping it on a similar tone. And one most important thing for me is feedback. So after every lecture, I'll be sharing the form with all of you. I take feedback really very seriously. So if you have any concerns, anything that I could have done better, or something that actually or in general, if anything worked out really well, do write in that feedback form. So last in the last cohort, I got feedback that there were a couple of people asking way too many questions. So then I had to uh, uh, basically start taking the questions at the end. If you have something similar to that, feel free to raise it. Then I immediately course corrected my actions, and it obviously helped us make the entire experience better. So if you have anything that you might want to give feedback about, go ahead and give it. And few things to ensure that you have got the calendar invite. Most of you would. In case even if you didn't, I'll drop a message on Google Groups, so you'll receive an email, and I'll also share it on Discord so that no one misses out. I have not added a few people onto Discord channel Ajola-2021 because I didn't know the username. So I don't really know if those folks are part of it. So I would really urge that your Discord name, if it is your real name, that is much better for me to identify. Otherwise, like just ping me separately on Discord, I'll add you to the group, right? And after the first session, once I upload the recording, you'll all get access to a Google Drive where all the notes and resources are uploaded. I'm trying to make it a little more organized, but it has worked really well for first and second cohort. So until I'm actually building my platform, this is a nice hack that I've put in where I upload all my resources, my videos and notes onto Google Drive. So all of these notes will also be shared there, and you can access it for lifetime. Sure. Yeah. Anything anyone wants to add before we start? Sure. Ankur asked, is the Discord link shared on the email? Ankur, the Discord link was shared in the Google Invites welcome message, but I'll share it once again. I'll do it. Basically towards the end of it. So I'll share the Discord link. Sure. We'll start with the. We'll start with a really foundational take of system design. So this is the most common thing that basically when you search about system design on the internet, this is exactly what you find. And this is exactly what lays a foundation of basic designing any system. So everyone has heard of, like, we have API servers, we have load balancers and all of those parts. So how all of those pieces come together, right? So we start with this foundational topic, which obviously would be used across every single system that we design, right? So with respect to system design, when someone asks you what exactly is system design, it's we have a bunch of requirements. So everything starts from a product, right? So we have something to build, and we try to mold it into a system with when we run it on top of computers, right? So those kind of systems, it can be. So system design, typically people think about just high level stuff, like, so that is one kind of system design. But in general, a true system design is where you build an application. It could be a module, it could be a service. Like if you are in a microservices architecture, your system could be an independent service working in a silo. It could be a massive architecture that you are asked. Like for example, if say building Instagram, that's like a very massive architecture that you might want to build. So that comes under system design. Building an independent microservice comes under system design. A module, which could be like a library, wherein low-level component interactions, throttling, doing retries, doing configuration management, those part also comes under system design. Applications, basically the web and the mobile applications of it. So this entire spectrum of product development, you can apply, or while designing any system, you can pick any of this and build one. Right? So translating requirements into a working homogeneous system containing heterogeneous components is what system design is. So few topics around system design is, first is architectural design, where what we see is from the bird's eye view how our macro components are designed. Like how does your system look like from a bird's eye view? So this is typically how you see that your request is coming in. You have a load balancer. That request is going to one of the backend servers. That server is connected to a database. That database has a cache in front of it, something similar. So this is an architectural design that we see from a bird's eye view. Okay. Then comes logical system design. So this logical system design is mostly around logics, mostly around algorithms, mostly around your business logic. Like if you are building Tinder, how will you ensure that a person that you have swiped left or right already is not shown again? That is the business logic. If you are building a bank, and what you want is you want to write a transaction where money is transferred from one to another. Like, so this, why actually designing this is really critical. I'm just putting a random question. So why do you think it is important to do a great business logic design? To do a great business logic design also. Why?
Ultimately, the product is the main thing. I mean, the customers have to use it. So if the business functionality is not met, the product is not met. So I mean, I think business is the first thing, and we optimize for the business, all the other things.
Nice. Anyone wants to contradict to that idea? So what Varun said was that a business comes first, and if you don't really have a great business, yeah, anyone wants to contradict that? No?
Maybe
Basically,
businesses can pivot.
Hmm.
Business logic can pivot over time. Features can keep changing.
Hmm.
But your underlying infrastructure systems, if they are robust enough, then you should be able to keep scaling up and modifying and refining features over time.
Nice. Another great view. Anyone?
I guess it's more sort of a roadmap and like what things you
Hmm.
have right now and what can be accommodated based on the roadmaps of the business logic which are there.
So overall, the points that have been covered are really interesting. First is extensibility. So how extensible is your code? How extensible is your business logic? So why is logical design also important? Because while designing any system, if your low level code is not extensible enough, for example, if you want to change your database provider from, let's say, SQL to NoSQL, how easy it would be for you to make those changes, right? So that is where a layer of abstraction or a DAO layer actually comes in really handy, right? So that part. So how if your business is pivot, but your core components, for example, your auth system might not. If your auth system is an independent business logic of its own, maybe a separate microservice, then even if your business pivots to a different idea, your auth layer might not have to change a bit, right? So understanding the extensibility while doing a business logic design is really important, right? On how to break those components. So with respect to architecture, it's simple. You are already given those macro components, but it is a little tricky when you are doing it at a logical level, because there is no clear separation. You can very well do it things very quickly, write a bit of spaghetti code and get things done. But keeping things extensible, understanding where to fence your business logic is really important. So this comes under extensibility. Another great point that was brought was that business comes first, because and I agree to that. Why? Because agar business nahi hai, then engineering has no role to play because job nahi hai, right? So it is always your product and business would always come would always come first. So sometimes you would have to you sometimes your engineering effort have to take a back seat. It's a harsh reality. We are all engineers. We want to write the most efficient code, build the best system out there, but sometimes it is not possible. Sometimes you would have to succumb to the business requirement. Let's say they say that, oh, I want to launch video calling feature in next 1 week. I don't know how you guys do it, but in next, if you are trying to keep things extensible, do the best sort of abstractions and whatnot, it would require more than a month worth of effort. But is that possible, right? But that video calling feature need to roll out in next 1 week, because in India TikTok is banned. Let's build another TikTok clone and earn money out of it, right? So if your business is there, then your business hack, although you might be incurring a bit of technical debt, uh, writing writing very shitty code and stuff, doing bad design, but that is okay. Your business has to survive. So usually engineers don't think from that perspective, right? We always think, ki, Arey, our senior management is like, hey, ki, isme kar do. But the main sentiment behind that is always that they are trying to save a business. Right? If your business is not there, your job would not be there. Right. So as an engineer, we always wish to build a best system, but sometimes it is not possible. But if you have a leverage of time, then you would always go for the best system from architecture point of view, the best system with respect to business logic, which is extensibility more often than not. And by handling the best, by basically modeling it the best way to handle scale on the low level side. Like for example, applying the best set of locks and mutexes and optimal locking, pessimal locking, and whatnot. Right. So doing those parts is also important, but only when you have enough time to do that. Right. Basically, this is a harsh reality that I would want every engineer to be aware of. So I typically say that we should not be doing a premature optimization of our system that we are building. Yeah, Pratha?
So, would you say that the logical design would be the most abstracted service out there compared to the architectural and physical
Yes.
design,
Yeah.
seeing it needs to be extensible?
Yes, because architecture is typically a macro component. So you can just change your MySQL into MongoDB, right? But your logical, if you change this thing, then if your logical level, if you just have one big file where you are making database connection, firing the query, and that is where the business logic is also written. What would happen is if you change a database provider, and now your application, now you have to go through an entire business logic to see how will you incorporate those changes. But if you have a separate abstracted layer in front of it, which makes all the database queries, you'd have to just change that layer. Like instead of firing SQL queries, you would fire MongoDB commands.
Yeah, keeping a service layer kind of thing.
Keeping a service layer. So adding abstractions, and basically that is where OOP concepts comes in really handy. So that is part of low level, but it is really important to understand the, okay, this is a really critical one, because if your low level is not supporting the abstractions that are or if your low level design is not supporting the abstractions needed by the high level design, then you are creating a very strong coupling to a certain provider. Like for example, most of the Indian startups are right now based on AWS. You assume that you are using SQS, SNS, or some sort of AWS service. Now, if someone says you, or let's say if AWS basically increase their price by 2x all of a sudden, and now you say, yeah, this is too costly. Microsoft is giving us a cheap plan. Let's move to Microsoft. Would that be possible? Because if your low level code is not abstracted enough, you would have a very high coupling between you and your cloud provider. Like this is an extremely extreme example, but you can actually very easily migrate it to like just changing a database provider from SQL to Oracle. Right? There might be few changes that you might have to take care of, but you would always need to have those things ready. So so to ensure that you are not strongly coupled to a certain system, your logical design is also really important.
I think payment gateway is a good example for that.
Great
Right?
example. Yeah, great
Like
example.
Stripe, if you need Stripe, and then it's simple like APIs and all. But if you need some other payment gateway, then you have to like abstract it out. Like
Great example, Nikhil. Great example. About a year back, when ICICI had that जो है वो massive fail. It was ICICI or HDFC. Within a day or so, all the companies had to move to a different payment gateway option, which is where Cred and a lot of companies actually appreciated their engineering teams on Twitter. That they said that they pulled it off within few hours, and all the payment basically again started working. Something major happened about a year back.
I guess it was Yes Bank and Paytm.
It was Yes Bank and
Oh.
Paytm. Yeah.
Yes Bank and
Because of
PhonePe, because
PhonePe, sorry, PhonePe. Yeah.
Yes
Yeah,
Bank's
yeah,
are
yeah, yeah.
as in backend services.
And then basically within just 24 hours, company had to move to ICS and basically other one. Yeah, that's where it happened. So if they did not write great code on, or if their low level was not abstracted enough, the time to migrate to a different system was much higher. A great example. I'll just make a note of it.
So one question here, Arpit.
Hmm.
So usually these things need to go hand in hand, right? Because like your business priority as comes first. So abstraction should also be like a hand-on-hand thing which needs to go in parallel, or is it like something to be decided at any point of time?
That's it needs to go in parallel, but it doesn't always. See, the business would always want to prioritize the execution. Right? They would want things to roll out as soon as possible. So that is where a lot of if you see in your company a lot of shitty things like a very bad DB design or a very bad architectural design that you made, that would not have been made consciously. Oh, sorry. That would have been made actually consciously, because they would have to do that rollout within a day or two or something like that. Like so, typically it goes in parallel, where you'd say ki, acha, your business, your high level architecture and your low level thing should go in parallel, but that's not how it goes, unfortunately. Okay. Then the third design that we don't really have to worry a lot about, but it is critical because of advent of clouds and all, like AWS, Microsoft, Google and all. A lot of things have been abstracted, but basically from the context of cloud, what we definitely want to think about when it comes to physical designing, we have to think about we have to think about input output interfaces, storage, specifically, like how would you store it, what kind of disk would you pick. Like if you're on AWS, you can configure IOPS for your database layer. How high should that IOPS be? Because with every increment of IOPS, you are charged money, right? So you can't you can't really have a really over provisioned infrastructure. And but if it is under provision, trying to save cost, but it might not give you best performance to the user, right? So there are lots of things that you would have to think about. Like coming to that, you have to do capacity planning. Like how many servers would you have to run? Like, so while designing the system, we had one load balancer, we had like 3 dabbas of API server. But in reality, your SRE or DevOps team would be the one that would be configuring that would be defining the auto scaling policies. Like when you receive 100 requests in a second, have 5 machines. When you receive 1,000 requests in 1 second, have 10 machines. Like all of those policies are written, which does that nice capacity planning. Okay, these many machines would be required to handle this much of traffic. And it all depends on how good your logical design is, how good your architectural design is, how good have you or how better have you handled your database logs and all. So every service is unique. Every service has its own set of things that it needs to worry about, like basically database locking and basically queuing, high network IO and all. So all of those parts needs to be considered while doing this capacity planning. So these are typically all back of the envelope calculations, but these comes in really handy to make good decisions. In week 6 or 7, we will dive deeper into this and see how can we make great choices, how can we make great design choices depending on our assumption of response time, incoming traffic, and expected response. So how to make those things. Then with respect to hardware, like after with respect to hardware also उसमें आ गया, how big should your CPU be, which program should you run on your GPUs, right? How big your RAM should be, all of those parts. So that is also important, because if you are doing machine learning sort of things, then you might want to have more cores. Basically, you might want to go for CPU, you might want to go for GPU versus CPU, right? Because if you use GPU, you might get a much faster performance, or you will train your model much faster. If you go for CPU, it's very limited by the number of cores, right? Then comes backup, restore. All of these things needs to be considered while designing your system. So it's not that for every system that you would have to think about it, but in most cases, this is where the high level view of your system should be. Like, you just think about it. One question I'd like to float around, which is that one system, like that one system you admire the most, like you would leave your current job and go work in for that system, and obviously why?
Like not exactly like I would like I'll just try to
Achha,
add.
not leave the job, but you
Huh.
admire the most.
Like from my experience, I'll say the physical design is the one which has kind of like in the recent few years solved most of the scalability problems. Like if you see startups which are there in the current scenario, I don't think any of them would have scaled even like in the past 7 years. Like I'll say like I started college in 2015 and I was not from CS background, but still I never heard of AWS or anything even till 2019. I'll say like even in college I did not had any CS friends talking about AWS or anything as such. So and like from what I see as an experience, 2019 or 17 is as in 18 19 is the part when everything started to explode, all thanks to AWS and the cloud providers. Before that, like if you see, there were startups, IBBO, Make My Trip, but were they able to scale at the rate now startups are able to scale? So I'll say the physical design is the thing which like Amazon
It has basically
given.
changed the entire spectrum. Well, I'll just give a very short example. Instagram, in first year of operations, they had 14 million users, 3 engineers. That's it. 3 engineers managing 14 million users. That was insane. And they were cloud native. They were on AWS. And basically that is exactly why you can have very lean team. If you guys have watched Silicon Valley web series, you would have seen how difficult it is to manage an actual on-premise infrastructure. A
Correct.
lot of companies had to do that. But with
I
the
was
cloud,
I was about to say Instagram too, because currently, if I mostly like admire the whole Django background. So it's scaled on a monolith. That to Django as a monolith, they have carved out the entire system.
Yeah.
So it's still amazing how they did that. Like not breaking down into multiple microservices and
Microservices,
keeping
yeah.
that whole
Yeah,
monolith kind of thing.
that's really well. We will be covering a few systems of their in depth in the second, third, and fourth week. बहुत मजा आएगा उसमें तो मतलब Instagram is something that I really admire because 3 engineers, 14 million users, 1 year of operations. मतलब hats off. Okay.
And also,
Any-
just one more thing. And also, like I'll say, in physical design, there are a lot of things you won't actually know unless and until like you see in the background what all things are done. You simply spin up a like as in when you say I want this much IOPS, but like the physical infrastructure which is needed on the back end to basically process and like create a software defined solution for that, which AWS Microsoft has done. That is, I'll say, like
that
this
is commendable. Yeah, yeah.
of the challenge.
Yeah.
Because like even on interface, like even if you go on real life servers, there aren't like more than 100 gig NICs out there. Most of the servers right now, like even like I'll say more than 50% use 1 gig NICs. Right now, the trend is starting to change to 10 gig NICs. So I'll say I'm not very sure about AWS, but I can tell about at least the company I work for in their backend infrastructure. 10 gig NICs are also not very famous, and like at least till now, but I'm not sure how AWS is doing that, or Microsoft.
Well, this is well, with the advent of cloud, well, it is so easy for anyone to start a company, especially a tech company. Well, it doesn't really take a lot of efforts to basically pull that off at any scale. Okay, which application or which engineering thing you guys admire the most? Like, and why? Like, for example, CRED or CultFit or any such systems.
Yeah, I would say WhatsApp. They have done the same job, maybe more than that, with IT, and I mean, if you see messaging infrastructure, see the latencies and the way they started the product. I mean, they started with a very simple product, but the scale at which the simple product operated, it's massive. Like, you know, when you push the message, you can do polling, you can do push. I mean, if you want the latency to be low, I mean, it's a push. If you are managing a push, I mean, you have a lot of problems from thundering herd to like a lot of problems when you are dealing at that scale. And I think very simple product to a massive scale. That's what I admire.
Yeah. Any other system? Basic WhatsApp is a great example.
I think PUBG is also good because
I was waiting for this. Yeah.
because
PUBG.
so many so many number of players, they have to sync and they have to find the scores. Like it's like too many things are running, like multiple things are running, right? So how they manage that is like kind of like marvel kind of, I think.
Okay.
Arpit, I really like YouTube. YouTube is my favorite application, and I really like the way handle the scale. I mean, the day when Gangnam Style just broke their system, and they had to improve their system. Then they came up with the when TikTok started rising to the fame, they came up with the YouTube Shorts. So in the small time, the way they're coming up with new ideas, and you hardly see YouTube is failing, right? It's not getting loaded or something. So this is something I really admire as a backend engineer, that team. The fast way they come up with new ideas, and the trust that they have with the users. Like if YouTube is not loading, you think your internet connection is not fine, right?
Exactly.
So you don't doubt the YouTube. So for me, YouTube is the system that I really admire.
Yeah. Also, the gigantic amount of data that they store, right?
Yeah.
It's
That's
amazingly
insane.
huge.
Yeah. Nice. Great system. It's great that you guys are really aware of few things, but go ahead and read their blogs. Just skim through them. They have a lot of content out there on how their engineering things are driven. You would get some really great sets of insights on how they've done it. I'm not sure about PUBG, but definitely YouTube and WhatsApp architectures are out there on their blog. So you can go ahead and read about them.
Like one example I had to add was Zerodha, or like basically
Yeah, Zerodha.
because like from my experience, these are like products which are like dependent on many other variants. And from what I know, Zerodha does not use cloud because they'll have to need to maintain that latency and need to be on-prem and nearest to NSE's data centers where actually the processing happens. So building a product which is solely dependent on someone else is kind of, and your scale depends on how they scale. So I'm not very much sure how exactly they have done, but this is an interesting thing which I was kind of researching, but did not like find much details around it.
Yeah, even
Actually, SEBI has actually shared an architecture. If you want to build your own Jebo discount brokerage company, you would have to follow an architecture like this. So SEBI on their official website has a proposed architecture. So you can go through that, and most probably Zerodha had to be compliant to that. So that would give you an idea.
The Zerodha CT also came on HasGeek. Like there was some series on systems architecture. So he gave a pretty detailed bird's eye view of how Zerodha functions. So probably you can check it out too.
Yeah.
I'll share the link on Discord.
Yeah, please do that.
yeah, even on the Dream 11, right? So they also have some interesting way of solving their problem of scalability during
But
high
Dream 11 Cup, their challenge, since they are cloud native, I've gone through a bunch of their videos. It's all magic of AWS. It's all magic of AWS. They would have to do a deal of great low level design, but going by basically going by the content which is shared outside, it seems like they are heavily reliant on AWS for the scale on basically handling those surges and all. But obviously their code has to be written that way to handle that much amount of concurrency. And obviously you can have 1 million people joining a contest. How do you ensure locking? By the way, we'll be discussing almost every single one of this during the course. Okay, how to build Dream 11, YouTube video ingestion pipeline, messaging on WhatsApp, and Zerodha ticking. We'll be discussing all of those things. So yeah.
Another great example is Amazon itself, because recently they had Prime Day, and the amount of requests that their services like DynamoDB and SQS handled was like amazing.
Amazon, when I worked at Amazon, I saw the scale, I saw their prediction engines, and I was just blown by the prediction engine. They had a per minute prediction of how many orders would be placed with a certain level of confidence, and that bar and that depth was, and basically the band was this thin, right? And the curve actually was within that band. It never went past that band. It was such an amazing detail around how they, just imagine if their prediction system is that good, how much of data would they have required? What kind of systems would they have done? They can predict the accuracy. In this minute, they would get this much of data. So I was there on call during the Cyber Monday or the Black Friday sale, and I was just going through their system, and we had this metric how many orders are placed, how many messages are sent, and I have two of my great friends working for the Kinesis team. So there I get the numbers of how they're doing it. It's pretty amazing.
Just to add on the on Amazon, at least I know Amazon also relies on very various other competitions which are there for themselves in the market. So just adding to that, but I'm not very sure why Amazon does that, but at least it does. It does depend on various other competitions.
For example, CDN issue. The recent CDN issue that happened, which took Amazon down. Amazon has CloudFront. Yeah. But even when I think it was Cloudflare that went down, or no, it was Fastly went down.
Fastly.
So when Fastly went down, Amazon also got affected, and I don't know why that happens, but
yeah, and also Prime Video completely runs on a different CDN provider other than CloudFront.
Yeah.
One question here. I mean, recently, I mean, there have been many cases where we have come to know that those very good systems that are built have been hacked by many anonymous hackers, and their details have been put online for sale and everything. I mean, did anybody come across this um, thing? I mean, there was an app called Upstock, right? I mean, they were hacked. Their system was hacked, and the details were put online for sale.
Domino's
So-
had this, right? Recently.
Yeah, Domino's recently, massive one. Unacademy had this. I was part of it. I was part of it. It was my birthday, and Unacademy was hacked. I spent 3 nights straight. We flipped our entire infra. Malab, every single server was rotated. Every single. Malab, I had it because I was the only. Malab, me and 2 others. We 3 guys. We didn't sleep for 3 days, and we just flipped our entire infrastructure. Pura technical debt was like out of the blue. Karo rotate. Every single EC2 instance, every single SQS queue, databases were changed because data was breached. It was amazing experience, but it's really hard to keep infrastructure secure. And hackers find a way anyway. So, yeah.
So was it possible to find the root cause for it?
Yeah, I know. We found that root cause. Because well, you'd have to have those insights enabled to figure those things out. You need a lot of forensics to do that. If logs were not there, we wouldn't be able to find it out. It's really important. And then we started improving our security posture.
So, what are the takeaways from that? I mean,
that I'll share later. That is a separate section that I'll definitely cover. बहुत interesting है वो. So folks who got bored for these discussions, think about the beauty of the engineering challenges that these companies have to face. Like we don't really appreciate the efforts of companies enough to build these systems, right? And while building any system of your own, always think from these perspectives, like how well other similar product would have been built, like how they would have done. If you are curious enough to see this system is so good, how their architecture would have been, and you read about them, then you assimilate all of that information, you combine all of that information, and you can put it to your practice. It's just about igniting your curiosity around go read, explore. There is so much of wealth out there, basically knowledge wealth out there. Go read, consume, and build a great system. So now when we approach system design, it's really important to do those. So not just for interviews. I'm really not just to teach anything just for the interview thing. But in general, when you do a great system design, this is also applicable while you're interviewing. But in general, in real life as well, you'd have to define a scope. Any system is infinitely buildable. Like, so you can always keep your systems improving, but it is very important to put a fence around it. That this is my scope. This is exactly what I'm going to build. Otherwise, you will never be able to roll out your product, because every time you'll find, this is the new feature that I can add. Okay, I can make this thing better, and that would keep on going. Right, so this is where it is really important, not just from interview, obviously during the interview, but also while you're at work. It is important to put a fence around it, that this is my scope and I would be sticking to this scope. Right. Then comes two kinds of scope: functional and non-functional. Functional scope is typically the features that your end users would use. And non-functional is something that we all engineers love, like how system would scale, and it needs to be available, data needs to be consistent, it needs to be fast enough, and those parts. So functional scope is typically features. Non-functional scope is typically the engineering side of things, where speed, reliability, security, and all of those parts. So typically PMs or the product managers talk in terms of functional scope, and tech leads, principal architects, and other engineering fellow talks in terms of non-functional scope. But it is important to define what your non-functional scope is, because you can always improve upon that. And obviously PMs or product managers would have to define a functional scope for that. Right. So while designing any system, do not assume anything, because and ask critical questions. This is the most important part. Ask critical questions, because your critical question should not be something like as blunt as why this, why not that. but it should be very specific that it should course correct the direction. So it should basically change the direction of your product. Like, oh my God, I never thought about this. Or if this question is raised, array, we would have to change that other design. So your critical questions helps you shape your system into a basically with a better design. So it basically challenges your product and engineering decisions, right? If your critical question, like for example, how will you or if tomorrow we see a sudden surge of let's say 1 million users, how are we going to handle that? If we ask this sort of critical questions, then it becomes a really interesting challenge and it helps shape the product. I'll just yeah. Then seek clarifications. This is again an important one because when you are designing a system from scratch, there is lots of ambiguity. Like you can pick SQL or no SQL. You can pick a certain technology versus other. You can pick a certain language over other, right? So, and obviously with respect to architecture, like should you be using a message broker or a data stream? What you would be doing? So there are lots of ambiguities that you need to take care of. But picking one over other needs to be a conscious decision. That is while keeping extensibility in mind. So you have to seek clarifications on, okay, this is the requirement. Okay, this is clarity. Now, depending on this, we'll pick this stack. Right. So this picking up this is really important. Building systems typically comes in two flavor: bottom up, wherein you build all the individual component and they work together in harmony and you have your system ready. And another approach is incremental, where you build MVP version 0 and then you keep on improving and improving and improving. Typically, big companies, MNCs, like not really MNCs, but basically big companies like Microsoft, Google, Facebook, they all go for bottom-up approach because they think it through. Bottom-up approach of system design, I would have to like basically think it through that you would have these sort of components, you would do this and that, and you would handle scale from day one because you're expecting that whenever you'll roll out, you'll immediately go for 1 billion users and all. But with startups and at just experimental scale, it should be incrementable, or rather it should be incremental. With that, what it would mean is that you would build a very simple version 0, not really meant to deal with scale, and then see if users love that part, then we will extend it. Right? Then we'll add features on top of it. So typically, when the team is agile enough, you'd go incremental. But if you have a very detailed plan, you can go for a bottom-up approach. So both of them are okay, but there is always but basically you can pick one over other depending on the kind of work environment you are in or the kind of if you're giving interview, you can obviously you'd have to go for incremental. But there is one golden rule. Just you can like basically you can actually just go tattoo it on your sleeve. It's as simple as like start small and build on top. So you should not be aiming for a very great system from day one, but you should have that vision in mind on at least 2 hops in the basically at least 2 hops in the future. You need to have in mind so that your system is at least extensible for the next level of scale, right? So always start small and build on top. So this is a very important thing while designing any system. And what you would be doing is you would have to like basically define building blocks for your system. You would have to define relationships between them. So when I say building blocks, it's like you'd have an auth service, you'd have a feed service, you might have you might have a trending service, and how they talk to them, how they would basically communicate between each other. So this communication could be over HTTP, could be through a shared database, could be over a message broker. There are so many jargons I'm throwing because I just want to like help you. I understand that okay, there are so many things that we would have to know, understand, and learn throughout this course. So just bear with me for some time. Okay. So defining the relationships between them, on how they would communicate, what kind of relationship would we have with respect to data, with respect to responsibilities, like define communication layer between them, identify bottlenecks. This is an important one. So you'd have to identify the bottleneck. Like for example, after a certain scale, my SQL would not scale. So I would have to move to NoSQL. So in order to move to a NoSQL, what I would have to do? Like you'd always have to be 2 steps in the future to understand, okay, after a certain thing, my system is not going to scale well. So I would have to be ready to alter my system, right? Yeah, Nikhil?
Yes, so I had one question, like, so should we start with monoliths or microservices? Like, so I had this question, like, when we start with building from scratch, normally we build like a single application or monoliths kind of thing, right?
Yeah.
So is it okay when we say like monolith?
Again, no one answer, no textbook answer for this. If you're working in a startup, building monolith is always, if you're building a product, a brand new product from scratch. For
Yeah,
example, I'm
yeah,
building one to manage my cohort. I'll always write monolith because for me, time to market is important. If I build microservice from day one, I don't know my product is going to survive or not.
yeah.
Right. So then those microservices is waste of effort. Nah. Why? Let's build best example, Instagram. 3 engineers, one monolith, 14 million users, 1 year. Well, and now today they are worth more than $100 billion, right? So if you are building anything from scratch, obviously it depends on the kind of work environment you are in. If you're working at Amazon, if you don't build microservice, they would screw you. You would have to go for microservices from day one. If you're working in a startup, building something from scratch, and if the future is uncertain for that product or for that feature, then go for monolith and then worry about microservices later.
Yeah, like kind of it depends, right? Unless you have users, you cannot just simply move to microservices, right?
Exactly.
Kind of.
मतलब एक user one request per day पे कहाँ microservice. Right?
Yeah.
Yeah. So let's start building block, the most basic, but this is typically what you find on the internet. But here, throughout this thing, we will be discussing three really interesting things. So what we do is we start with basic requirements. Like, so what we do is, let's say we want to build our personal blog. So it's a single user blog. It has multiple posts. Each post has tags. You can browse by tag. You would have a search bar which enables reader to find an article. Blogs are ordered by time. Blog should support 1 million concurrent readers. I'm like really optimistic, but let's say from day zero, you are expecting 1 million concurrent readers, and blog should be available 99.9999% of time. And blog should load fast. Typically, this final requirement, this requirement is something that everyone says. Like your product should be fast, or your service should be fast, or the blog should be fast. The word fast is very subjective, right? For a service, 1 second could be fast. Like if you are retraining your machine learning model, then 1 second is fast. If you are processing video in 1 second, that is fast. But 1 second to serve an API request is too slow. So this is something that I would really want to stress. So whenever we are stating the requirements, always think about this, that are we being are we being subjective here? Because the requirement should be crystal clear. The requirement should be objective. Okay, this is what we have to achieve, and not subjective. Basically, nothing should be open to interpretation, right? Your blog should be fast. This should be like, my blog should be, or my page should load within 500 milliseconds, or my API should respond, or my server side computation of API should be less than 5 milliseconds, right? That is an objective requirement and not a subjective one. So blog should be fast. It's a very subjective one, which is open to interpretation. For some fresher, it could be like 1 second is too fast. For an experienced one, it would say 1 second is too slow, right? That should not how the communication should be. So always, while defining requirements, think about it. Your requirements should be always objective, where it is clearly defined on what to expect out of it. Now, this is the best part. Malav, this is something that I'm like really proud of. I try to model this thing so that, and we would be covering while designing any system, we would be thinking about all of these 6 things, right? So for example, even for a blog, this 6 things is something that we would have to think about. Any system you pick, you would have to design, you would have to define this 6 components of it. Database, which is basically your persistent layer, then caching, scaling, delegation, concurrency, and communication. Okay, let's iterate through them. Database is basically pretty obvious. You need somewhere to store the data. Caching is okay. Scaling, what would come here? Scaling.
Horizontal or vertical? Right.
Horizontal, vertical. That's a great point. What would come under delegation?
Message queue sort of system.
Exactly. So delegation is the most underrated. It is definitely the most underrated way to gain performance out of a system. So people never think about, array, they can delegate this work, right? So delegation is one of the most underrated way to gain performance out of a system. But we will go, but obviously along this course, we will go through the sections where we will be using delegations to optimize latencies to a single digit millisecond. Then comes concurrency. This is where, like, how will you handle these many concurrent users? So this typically comes under scale, but here concurrency is also with respect to, like, how will you handle these many concurrent users on your business logic. If you are handling threads, then mutexes, semaphores, locking to protect your critical section. Like, all of those part also comes under concurrency. Then the final thing is about communication, like how, or because your communication, it can be over HTTP, right? But HTTP is not the only option. There are so many things that you can use so that your end user can communicate to your system. For example, it could be HTTP based API requests, or it could be a gRPC system, or it could be WebSockets, or it could be raw TCP, it could be UDP. So there are plethora of options with respect to communication. We will go through obviously one by one. Which one would we pick and why? Right. So each of the above decision will actually define how your system scales. Right. So it might be a really strong case from day one to think about scale at a very high thing, but obviously we have defined it in our system that our blog expects 1 million concurrent users. Right. So given by the requirements, see how you, or what kind of decisions would you make on all of these 6 fronts, right? So, and if one of your front is suboptimal, so that would be becoming a bottleneck for your scaling. Like, for example, if your communication layer is working on UDP in which there are packet loss, so then you would spend days figuring out, array, I published this metric, but it never reached my database. Why? It was because of your wrong choice of communication protocol that you chose to use. Instead of TCP, you chose UDP. Right? These simple things, when we decide, it defines how your system scales or behaves or performs. Right? So it is really important to, like, understand all of this part. We will have to take into consideration all of these things to design a great system. With respect to databases, I just want to list down few databases that I could think of. Obviously, there would be more. Go through the list. Let me know how many. If you know every single one of them or heard of every single one of them, raise your hand. Nikhil, you might want to drop your hand first. Lower hand. Chala. How many of you have heard of all of them? Varun, great. Srisha, I expected Srisha to do it. Yeah. Nice. Chala, 2 books. I'm really happy. Yeah. In memory, we'll just Acha, Vamshi. Nice. So we'll just very quickly skim through them, and obviously along the course we will go through them and we will see where which one fits and why. Right. So in-memory databases, typically caches. Disk-based databases, are a normal MySQL server, MongoDB, and whatnot. Server database is something, a database that has its own server to run. Let's basically typically are MySQL servers or MongoDB servers, Elasticsearch, those part. There are databases which are embedded, which runs within the context of the application. They don't have a separate server running where the client is communicating to the server to get the data. These run within the same application. These are embedded databases. Then comes row-based database and columnar database. This is how your data is structured, and on either row-wise or column-wise. We will come to it on which one to use, when and why and how. Then comes graph databases to model graph relationships, where let's say user A follows user B, that's a graph A like this. So basically subject object verb kind of relationships. Then comes time series databases. These databases are typically on one axis, you would always have time, and then on y-axis it would be a metric. So these kind of databases are used for handling time series data, which is like, let's say CPU basically what's the CPU usage of your server. So every minute you would have one data point. So every minute your EC2 machine or your virtual machine would actually register key on this minute I have this much of CPU. On this minute this much of CPU is consumed. So on one axis you would always have time. On another axis you might have data points. So this is where how your time series databases are there. Then comes relational, non-relational database, SQL, NoSQL. Blob storages like S3, which doesn't really care about what's within the data. What it cares about is data is just a binary long object, and I have to store that object. Then flat file storages, in which you store flat files, but it's so basically flat file storages are typically blob storages, but you have a visibility on the data and you can query on them if needed. And storages for text-based search, so typically Elasticsearch. So why all of this thing? Because these databases, each one of them is designed to be performant for a certain use case. If you choose one database over other, you might get some pros and some cons, right? So you can model like, so if I ask which one would you pick for designing a blog, you can typically pick any one of them. No one is stopping you from designing a blog from on your in-memory database, let's say cache. Like no one is stopping you from building a blog on that. You can use embedded database if you want. You can use columnar way of storing data. You can use time series for a blog. Why not? You can pick that part to build blog on top of that data. Right. So every single one of these type of databases, they are optimal for a certain kind of use cases. It's just that we all have to be aware. If you don't even know that such kind of database exists, how are we going to make a great choice? Right. So this is more towards we trying to be aware. Okay, these kind of options are there. So how would we use them? Right. So which kind of database would you use? Yeah, Umang?
I just wanted to ask. So I never knew about all these kind of databases. As in, should they be called databases or not? Like let's consider time series database. So I'm not very sure how actually they are storing the data, but ultimately they would be storing in some form of column or row data, right? So how exactly does it?
No, every database has a different kind of storage. Not everyone stores in row. See, you can model time series database on your MySQL or on your Postgres. There is a database called TimescaleDB, which models time series data on top of Postgres database.
Correct. So that's what basically it is. Time series is a type of modeling which can be implemented on a traditional database also, right?
Yeah, but that might not be that optimal.
Okay.
Right. So if you for example, if you are talking about time series database, the way a database like InfluxDB or Prometheus is modeling it versus you are hacking your way into modeling it on Postgres.
Basically, the queries or fetching the data out or
fetching the data might not be optimal. Obviously, you can build any database on top of any other database which is there in the list. You can crisscross anything. You can model columnar storage on non-relational databases. You can model graph database on SQL storage. You can model graph database on MongoDB. Right? You can model time series on SQL storage. Right? No one is, and obviously Elasticsearch is used for time series data as well. So no one is stopping you from doing that, but that might not be the most optimal way to do so.
And also another thing, at least what I think is storage should not be considered in databases, right? Because storage are different classes of objects altogether.
That's not really. I mean, you can use S3 as a database. To be really honest, I've used S3 as a database.
It is a data, yeah, but on a database level, basically, it does not store. How do I say? I do not have the exact.
What's your definition of database?
So database, it is storing granular data. Because S3 stores object data, right? Because that comes into.
But if object is the granularity that I'm operating at.
Yeah, so that's what it is a generic definition, but at least I feel feel storages are a different class
Hmm.
altogether. They will not be
That
embedded
could be,
inside
but these are just types of database. Matlab, you can model, you can use S3 as a database,
Okay, got it.
right? So there is obviously matlab, you can question a lot of part. It's just that there is no clear definition about what is what, right? Matlab, if you would want to call S3 a database or not. So when you say database, you need access to a certain element of it. You can model. So basically, S3 is just a glorified file directory.
Correct.
You can model a file directory to act as a database. Let's say every user can post, your user ID becomes a directory and your blog post ID becomes a file within that. Can't you access it at a granular level? You can.
No, what I kind of meant was basically S3 will have something which has embedded size. I do not know how to say this. Like when you fetch data from your database, it will have some form of text, but S3 will is S3
S3 maybe I can have text.
but it will be on I'm not sure, but it will be in the form of object, right?
Not really, not really. This is we will come to it. Matlab, we will anyway have a massive discussion around S3 and databases, and that's where we will come to that part. Yeah, Kaustubh?
All this
Hey,
is-
Arpit, so I've never used S3. So like, does S3 offer like a query language that allows us to retrieve blobs, or like, how does that exactly work?
S3 is similar to your Microsoft Azure's storage. What's called? It's Java Cloud Storage that you have.
You can just relate it to Google Drive.
Yeah.
S3 is just like a Google Drive.
Yeah, S3 is like Google.
Okay.
But you can use a tool called Athena to query from S3, and you'll get similar data in form of a table. So
Yeah.
technically, yes, it is possible.
It is possible.
Okay,
So,
yeah, I'm not aware about Athena. Like maybe
yeah,
I'll have to-
there are lots of ways to do it. So basically, I agree to your point that it is a storage class. But if I add that definition, storage class, but at the end you can use. But now actually the thing is the lines are getting very blurry. Matlab, a database, like for example, who would have thought that you can model time series database on a SQL storage? But with this thing, every database is trying to be every other database. For example, you have a full text search in your Postgres DB as well. Right, so you can skip using Elasticsearch to have a full text search if you are already using Postgres. Right, you can have basically you can change the storage class of your MySQL database to act as a cache. So every database is trying to be every other database. For example, MongoDB is now supporting ACID properties. Right, so with time the databases are evolving and everyone is trying to be every other database. So which one would you pick for a blog and why? Typically what we do is we start with the most common choice over here is basically picking SQL, because everyone is like really aware of it, okay? How SQL works, how would we model tables. So what we would do over here is we would pick SQL, and it is not really an obvious choice, or it might not be the most optimal choice for it. But what you should be thinking about this is where the attributes of it, or the columns that we are picking here, are basically kind of attributes of those entities. For example, user as ID, name, and bio. Right. So given this thing, so if you're modeling it in NoSQL world, you would have a JSON document, and all of this could be attribute. But typically, SQL way of thinking is very easily translatable into any other NoSQL-ish way. Right. So what we would do is we would start with a very simple SQL-like thing, and then if needed, if any alteration is needed with respect to change from SQL to NoSQL, we would make that. Okay. So we will take a break at 5:15. I just want to cover this part, the overall schema of it, so that we can cover database and caching in the next one hour. Okay. So let's.
Hey, Arpit. Just a question. So by solving around data, do you think it makes sense to separate the data from the metadata in terms of the data modeling? Like in terms of, for example, a blog, the actual text for the blog should be treated separately from the metadata.
That's a design choice. That is actually a design choice. You can choose to store it in your database. We will actually come to it. I'll basically address your point when we reach there.
Yeah.
Okay.
Sure.
I mean, generally, how I start the design is with the API, because I mean, instead of going into the entities and all, what are the APIs we are going to have, and how we design the entities around. I mean, we can optimize the entities.
You can start exactly. So basically, you can start with any approach. You can start with database if you need. You can start with APIs if you need. If you need to do it that way, Madam, it's obviously a choice on how you want to do it, and obviously, I'd say quite often that there is no one way to design a system. Every system can be designed with hundreds of ways, right? You can pick any which works for you, right? It's important to just cover it from one way, and which is where I pick database first. Even but you can start with input output or basically your API side of things, right? So with respect to tables, what we would have is we would have a table for users, although it's a single user table, but keeping the future extensibility in mind. Let's say we have a table called users. It has ID, name, and bio. You would have a table called blogs, in which you would store the blog ID, blog title. You would have user ID on basically who is the author of this blog. You would have published at basically when this blog was published. You would have body. You would have an excerpt. Excerpt could be your small set of line or your basically a one-liner that makes it catchy enough for user to click on that blog. A slug. Slug is typically a short form, or basically it is like your URL. When you add, like for example, if a blog, so slug for a blog is nothing but your titles, lowercase version, spaces replaced with hyphens, so that your blog becomes SEO friendly. So when someone searches for something, and if it is there in the URL, search engine gives it very high weightage, right? And one field which I added is deleted. Okay, so is deleted is a field which would mark if a blog is deleted or not, right? And here this is typically called as soft deleting. So when we build any system, when we are trying to delete something, we have an option to either do a hard delete, which means firing a delete query on the table, versus marking it as is deleted, which is basically tombstone, basically adding a flag which says that this entry is deleted, and handling it on the application side that if you read something from a database, you would skip the rows that have is deleted equal to true. Why so? What would be the advantage of doing hard delete or soft delete over here? Varun, your voice is very echoing. Can you just check your mic or something once?
Basically, in cases of recovery and like you want to restore the data.
So importance of it, this is recovery.
Or like archives also you can use it for in case for reference.
If you want to know when the blog was deleted.
Okay, if I want, so then is deleted should have to be a timestamp then, na?
So updated it will also be a field here.
Updated that could be it.
So audit purpose, I mean, does it serve?
Yeah, for auditing also you would be needing it. So basically most of you would be aware of that. So is deleted is when you do a soft delete, you can get recoverability. Like for example, you can temporarily suspend your Instagram account. So what it does internally, it just marks it for soft delete so that you can recover your account back. Right. So similarly, if you have if you fire a delete query, it would do a hard delete. If you do a hard delete from the database, your data is not recoverable anymore. So you cannot restore your lost data, or you cannot restore your deleted data. So if you would want to, this is a very important design decision, where when it comes to deleting something, would you want your data or your deleted data to be recoverable or not? If you want that data to be recoverable, you would have to do a soft delete. Okay, if you don't want your data to be recoverable, you can do hard delete totally. Okay, another great advantage of using is delete is on database performance. Like if you do a hard delete every time, and let's say the number of queries or the number of deletes that you're receiving on your database is quite high, your data will be fragmented. Your data will be fragmented on disk. Okay, because it would have to rewrite. What happens when you delete? When you delete, the disk IO happens and it basically deletes the entire row ka data. Right? And once it deletes that entire row ka data, it might have to rebalance the B. If you're talking about SQL, it would have to rebalance your B plus tree on disk, which takes a lot of time. Right? So delete operations might not be really that optimal because your database have to do a lot of disk IO when it is doing hard delete. Versus when you're doing soft delete, what you can do is when you're doing soft delete, you can just mark it as is deleted, handle it on the application side, and once a while perform hard delete. Let's say if you'd want, let's say you'd always want to perform hard delete, what you can do is you can run a job at night or during the VRs when you expect a very less traffic. You can run a job that deletes the data in batch. So all the is deleted one, it would perform a hard delete. So this way, your database engine does not really have to perform a lot of disk IOs while doing a hard delete every time. So it can batch the disk IOs together. And doing it during the VRs obviously has obviously it would not affect a lot of performance of the database. Now coming to a great question which was asked was about body, this thing. So would we store, or rather should we store the body of the blog in the database? In this table, we typically store the body of the blog. So like say your blog is like, let's say 5,000 words long, right? It's a really long form essay and you have 5,000 words or blog long. So this body would be a really big of an object. Should you be storing the body of the blog in this table?
No.
No. Okay.
Because
Maybe few,
see, there will
maybe
be a lot of, sorry, there will be a lot of page. I mean, each record will span multiple pages, and whenever you are iterating or whenever you are trying to search in the blogs or do some operation in the blogs, you may have to load it into the memory because of the underlying structure.
Okay. Yeah.
maybe not the full text, but starting like let's say 100 characters.
That's part of excerpt here. That's the first part of your text. Basically, the first 1024 characters could be. So if you are not storing body here, where would you store the body?
A blob.
We can use blob storages.
You can use blob storages for that.
One question I have is the scale, because you said 5,000 words. Word is what, like 2 bytes? 2 bytes times 5,000, that's like 10,000 bytes. That's only 50 kilobytes per body. That's something that like a traditional MySQL or relational database can store easily per row, right?
Yeah, that is okay. See, it is just basically taking it to an extent. It is not a best decision. We are just discussing it. Basically, what are the possible ways to do? Everyone would store it in the table, but just understanding what could be the cons of doing such thing. If we take it to an extreme, let's say 5,000 words per, we scale it up to, let's say 5 million words per block due to any reason, right? So just taking an hypothetical situation and seeing where can we store this. A great example here could be storing images of the blog. I have this point again where we would be doing where should we store images. So this would make sense when we talk about images being stored in the database. Right? So we will come to that on why would, or basically how we should be dealing with this. With respect to typical size of blogs, it is not a big thing to store the body of the blog in the database because it is never going to be that massive. So let's say an average length of a word is 5 characters, and each character, if you take UTF-MB4 encoding, it is 4 bytes. And let's say you have 5,000 words. So the kind of thing that I'm doing, it is called as back of the envelope calculation, which is where it would help us make the decision that should you be storing body in the table or not, right? So if I have five characters in a word, correct. On an average, if I have 5 characters in one word and there are 5,000 words, and each character will take 4 bytes of storage. If I'm going for a UTF-MB4 encoding, so then it would be, this is 20 and this is 5,000. This is 5 2s are 10 and 4 0. About 4 zeros, no? 1 2 3 4. Yeah. So about 100K. So about 100 KB of storage would be required to store this much of data. Would your database layer would your database engine would have any problem storing this much of data in one row? Right. Although it seems like it is not going to be a problem, let's understand how it could be a problem by taking it to an extreme. We will come to this design, but just by taking it to an extreme, that should we be storing images now instead of 500 words? Let's say we want to store images of megabytes, right? Srisha, go on with your question.
Hey, Arpit, so in my opinion, back to the body. So if it turns out that the body is being accessed by a lot of people and being updated constantly, we should also consider like what is the throughput of update and how can it increase? And also if it's something like Google Docs where there are multiple people updating it, moving it out to a different storage altogether would make sense.
Yeah, correct. So a great point brought by Srisha is about if the document is collaborative, then what? But this is a simple blog where once the blog is published, it is published, minor updates would be done here or there. Think of it like Medium, right? It would not have a lot of updates flowing in. It would be a very read heavy system. Yeah, Rajendra.
Hey, my question was about cross-referencing. So I see that we are thinking about tags and blog ID and tag ID. But if you are to implement cross-referencing as a feature, would it impact, or how would it impact the design?
Yeah, we will take that. We will take that. What would happen when we do that part? Okay. One thing that I would definitely want to cover here is how should we store images? Like if we think about this blog, one body of 100 KB might not be a very big deal, right? But the way your SQL storage or the database storage stores, like if your data is stored in a row-based storages, what would happen is your entire row would be stored in a contiguous memory location, right? So this is one row, then the another row would be stored, then the next row would be stored. So now what would happen is when you are iterating through, let's say, all the blocks of your table. Okay, let's say for some use case, you would want to list down all the blogs that you have on the website, right? So for that, when you're doing it, and if you are doing it, you would have to your disk IO, when it starts from one, when it basically finishes reading one row, then it moves to another row, then it moves to the third row. It would have to go through that much of space. So let's say your body is too big. Let's say it's 100 KB. It would have to perform disk IO of that 100 KB and then move to the next one. So unless and until it goes through that part, it cannot go to that next location, right? When you are iterating the entries of your block. Okay, so even if you apply that select, if you are not selecting your body, still, since it's part of your storage, it would have to read that much of chunk and do it. So this is typically how your disk pages or disk block IO works. So when your disk driver reads something from your disk and loads it, it would load in terms of in a unit called a disk block. And when it reads those many blocks from the disk, it has to go through it and then it can read the next block. So if you are storing a very massive body or a very massive structure in your block, typically an image, your image could be like 1 megabyte or let's say 5 MB big, right? So and if it is there, then your database, in order to just read that one row of your database, and let's say your disk block size is 4 KB, so it would have to make those many disk IOs to read just one row of your system. So if you're storing massive objects in your SQL storages in which the disk IO happens like this from the raw disk, then it would take a very massive impact on your database performance, because now reading one row implies loading this much of data in memory, right? And then obviously when you apply select and you just pick a few columns, if you do so, then it would be basically discarding the other part which was read. Matlab, that entire read IO operation that it spent so much of time doing went in there.
No, but Arpit, here won't the indexing help in such a situation? If we have indexes,
how would you index it? If you index it
on a particular columns that we are needing for going through all the
exactly
blocks.
that's what, man. That's an optimization. Let's say we are not doing that.
Okay.
Malab, it's more about understanding the problem, right?
Okay. Yeah.
Right? Ki, matlab, what would happen, because understanding how the disk IO works, because it might, malab, let's say if you are designing, wait, let me give you another example here. Indexing would help where, but if your indexes are clustered, then it definitely won't. Okay, let's say you want to read a blog by an ID. Okay, and all you are selecting is just title of the blog and not the body of the blog due to some reason. Then your disk IO for reading that entire row would go in vain.
Okay.
Right. If you store images like this, if you store bulkier objects in your row, that would take an performance hit. Indexing could solve the problem if you're indexing like blog ID and user ID, or basically user ID and blog ID, and just reading those part and then reading the metadata of that blog. But still your indexes might just optimal for, it would just basically filtering it out. So let's take this thing a little deep on what would happen to the performance layer of this thing. So how indexes might not really help the cause. So what would happen is you would have a user ID. For this user, you would have blog ID 1, blog ID 2, blog ID 3. Okay. Now, while doing this thing, you would have a separate index which stores that. Now, let's say I want to render all the blogs of a certain user. Let's say user ID or your user U1 has just 3 blocks, B1, B2, B3. How these 3 blocks would have been stored on the disk? It would have been stored something like this. Okay. Now, if I am fetching, all I am fetching is just title of the blog and let's say tags of the blog. Or let's not worry about tags. Let's say I'm just fetching the title of the blog. Okay. But on my index, all I have is user ID and a blog mapping. Now this blog, when my database engine is trying to fetch the title of B1, it would still have to go here. Sorry. It would have to go to this thing, and this thing and fetch the title from it. For that, it would have to load that row. So if your page is too big and if it is unable to find title in there, it would be loading that much of data in memory. When you're iterating it sequentially, it's the worst time. It's the worst thing that you can do to your database when you're iterating it sequentially. But in general, if it takes time for your database engine to load that much of row, it would take a performance hit on your database.
Yeah.
Okay. So seems like a great idea. Indexes help you make lookups faster. But if your single row's size is too long, it will have an performance impact. Right. So that is why you should not be storing images and massive objects. So here 100 KB is still not that big. Right. And obviously this is like too big of a thing to worry about. But how your database engine actually stores. So what kind of columns would you choose here is also very important. So let's say if you choose something like a varchar or a type called long text. So it does not store your body sequentially in the row. So what it actually does is, so that is where your types of the, or your data types of your database comes in very handy. So what it does is it stores a reference to that. So for body, it would store a separate location where the entire body is stored. So your body would just act as like a 4-byte. So I think of it like a pointer to an object. So internally, your long texts are stored like this. So which is very efficient. So it makes your rows leaner. So if you have used something like a varchar, which and if your size is small, it would try to fit it into, and if it fits within the max cap of that row, it would store it there. Otherwise, it would allocate a different section where where this long text object is stored. So this is how it keeps the row leaner. And so that is another optimization that your database engine performs. So while designing this system, this is where the business logic design or the low-level design comes in handy, where each of this decision actually matters. How is the data structured? How will you deal with this? So yeah, Chandan.
Yeah, okay. How about storing that in the JSON format in the database row?
The entire block?
Yeah, entire block format JSON.
then you could have used NoSQL storage, no, directly.
Yeah, but I think PostgreSQL, we have an
Postgres
option.
supports JSON. So I told you,
Yeah.
na, every database is trying to mimic every other database. Postgres
Yeah.
supports JSON queries as well.
Okay, so I mean, when it comes to performance, where do you rate at? Will it be better as compared to, as with the example you gave, Varchar and normal if you store that in a character format?
See, if you store it in JSON, it would have to read the entire JSON in one shot.
Yeah.
If you're loading, so that much of data would be loaded. So how you are giving an experience to the user, it also depends. Like for example, if your images are too big or if your block body is too big, and you can make another API call to fetch the block body separately, right? So that also works. But if you want to give it in a single shot, right, then you would have to do it synchronously. So it depends on how you are designing your end user experience. Yeah, Pradman?
Also, coming to the point of JSON, how about like storing images to some place called Digital Ocean Spaces or S3, and then using that URLs?
Exactly. So storing images is actually very similar to this, right? So as our database engine, the way it stores long text is it stores a reference to a file location or to a location on the disk where the actual data is stored. Similar to that, which is what I'd want to cover. How should we store images? We would be storing images into a blob storage, which is meant for use cases like this, and we'd store a URL of that image on the here. In the database, so that our rows are leaner. Because why to store images on the database? Because of these performance issues, right? We will come to that. We'll come to that and this in the aage wala part. Right. One thing about tags here, what I've done is tags may I have ID and name. So tags is basically list of all the tags that I have in the database, and I have blocks underscore tags, which stores this block has this tag ID, right? So typically what we could have done it is we could have stored raw tag strings along with the block, but instead what we chose to do was we separate it out into tags where it stores all the tags, all the unique tags of my system, and with the blocks underscore tags tab, it just stores the mapping between the block ID and tag ID. What kind of benefits would this schema give us?
Same tag can be used for multiple blocks.
So space bach gayi. Because if you're storing strings and let's say if your tag is too long, it would actually consume a lot of space. Okay. What else? Search is faster.
According to tag ID, like which all blocks are there for a particular.
Very easy to find, but that could have been done at string level, but string levels are very expensive. So since tag ID would be an integer comparisons are much faster, right? So so blocks underscore tags mein tag ID ke jagah we could have used normal tag, which is a string, and let's say if the hashtag that you're using for that blog is, let's say, 50 characters long, right? So then for each of those entry you would be copying that 50 characters thing. So every block that having that tag, and then when you're searching it, you would be doing a string matching, which is insanely slow, right? So string matching is not fast versus integer matching. Obviously integer matching is lightning fast. So we are just reducing the scope. Instead of storing 50 byte or a 50 character long string, we're just storing 4 byte integer that represents a tag ID. So removing the redundancy. But the disadvantage of this approach is joins, right? Because now when we are accessing something, now we are accessing a blog and we want to fetch tags all the time, we are making a join between blog tags and blog tags to get the actual tag name. Yeah, Rajendra?
Hey, from a UX perspective, this is important too, because names are human. Tag name is human readable entity.
Yeah. On the front side, on the front end, we would be obviously sending the actual tag name.
No, where I'm coming from is by having these tag IDs, it frees up user to change tag names at will.
Yes.
Meaning I could change my tag names but nothing changes in the system.
True. That's a great advantage. That's a great advantage to have. Like, for example, this is typically the case when you have a category, when you're building a website like Medium and you have a tag called database, and you see that all the articles belong to SQL side. So you want to create another category called SQL data. You want to create another category called NoSQL databases and rename this into SQL database. So when you have this kind of schema, a great advantage that you get is you can change a tag name without altering any other thing. So you can rename a lot of tags, categories, and similar things in your system. Right. So just adding that one layer of abstraction. This is that abstraction that we talked about. Yeah, great point, Rajendra. Thanks for bringing that up. Okay. So by doing this, so this is a typical normalization of a database. When you normalize your database and you try to reduce the redundancy, you are incurring the cons of having to make joins, right? Because now to just get tags, you have to join blogs, tags, and tags. Right. So if you don't have right set of indexes, joins could be expensive, but SQL storages are meant to handle joins because that's the primary use case of it. So, but still joins are expensive. So always keep in mind, sometimes you would have to give up. If at scale, you would have to give up on normalization, although it's a best design practice to have a fully normalized database adhering to 3NF. But if it is not the case, you might want to give up on normalization to gain performance out of it. Right. So data types, one interesting data type that I wanted to cover was how will you store published data for a blog?
Timestamp.
Yeah. Basically, when that query gets executed, and we just use that timestamp.
Timestamp as in what? What's the data type there?
What about epochs? Unique epochs.
Coming to that. Chalo, debate kare. Epoch. Epoch in, let's say, milliseconds for now, or epoch seconds there.
You mean as in the Unix time?
Yeah, as in integer, raw integer.
Got it.
Typically, while designing a database schema like this, we choose date time, we choose timestamp, or some the typical choices are either we go for a date time or we go for an integer like epoch seconds. Which one would be better and why?
I believe date time will be better because it comes with a lot of operations. Like let's say you want to compare dates, it has some, it gives you some additional functionality compared to the raw integers.
Okay.
Range queries becomes faster with integers, right? So you could have date time. So
yeah. So date time objects. So basically, Varun, date time is not faster. Range queries are much faster on integers, similar to the optimization that we did for tags by storing tag ID instead of storing the actual string. This is the exact same thing that happens with datetime object. So when you actually store datetime, it gets serialized into a form of it basically gets marshaled and stored on the disk. Every time you are performing the query, it has to unmarshal the content, load it into an in-memory object that represents datetime. So you can think about it like your Java datetime object or your Python datetime object. You would have that, it would have to convert that and then do the comparison. When it is integer, reading an integer, performing those range queries becomes really efficient, right? So storing epoch seconds or epoch milliseconds, depending on the granularity that you would want to operate on, is much faster than storing datetime objects. Datetime objects looks very human readable and all, but it's definitely not efficient. Integers, CPUs are meant to process numbers, especially integers. They are meant to do that very efficiently. So try to model these things on integers. Matlab, it's really easy to do it, or it just takes a little more operations on the application side, where every time you're firing a query, you would have to convert your string or your datetime into an epoch seconds and then pass it on to your SQL query, but it's worth it. Right. So MakeMyTrip did that migration about 4 years back, where they drop all the datetime columns on one of the databases and replaced it with integers, and the database performance got boosted by 20%, which is massive. One thing that we did not really talk about is, apart from storing epoch seconds, there is another interesting format which you can store, which is YYYY MMDD. So if you are just storing dates, no? Just storing dates, not you don't worry about time, but just storing dates. If you just store by MMDD, it gives you best of both worlds. It gives you database level human readability, and it gives you power of it gives you power for integer comparisons. So you convert this into an integer, not storing it as string, but this as an integer. So let's say if I want to store today's date, which is 3rd of July, I would store 2021, not as a string, but as an integer, 20210703. Right? I can still make queries on the database, on range queries on date level. Plus, I will also get benefit of my database level readability, which I get from datetime objects, because now I can like read it as a developer, not as an end user. End user, you will still convert it to the time zone aware string and all, but this gives you the best of both worlds. Any thoughts?
I mean, there is one issue. I mean, let's say you post it now, it's date, right? I mean, here it is 3rd, but in some countries it will be 4th. I mean, you may have to store the time zone as well when you are doing this.
Yeah. So making things time zone aware is a pathetic problem. imagine we once we civilize Mars, we would have yet another time zone to cover. Acha, by the way, how should we handle time zones? What's the best way to handle time zones in the low level code base?
Store it in form of ISO string.
ISO strings is one. If you store ISO strings, if you're picking integers, then epoch. Always go for UTC. No matter which time zone you are in, always convert everything to UTC and store. And then depending on the time zone of the user, you convert it on the fly and send it to the user.
And
we could also store it as some offset from GMT, right? Or also tenantize the entire system.
If you can tenantize the entire system, that's the best. Yeah. But if you can't do that and you would want to handle it on the database side of things, so you can store ISO strings, you can epoch this thing. That's typically how. But basically converting everything to UTC and then storing it makes life much simpler, because then if your user moves from one geography to another geography and basically changes the time zone preference, your system doesn't really have to change anything.
So
another advantage is that browsers automatically convert UTC to the user's time zone. So you can directly send a UTC date and then it will display it in the specific time zone.
Yeah, basically like handling this on the front end side, right?
On the front end side, basically, yeah, exactly. So to summarize a great point by one, handling it on the front end side. So let the time zones be handled on the front end side, and your backend system should work on UTC, because that's the standard time. Because if you handle it on the UTC, you can convert into epoch and date time, and the things become very seamless. You don't really have to worry about time zones from the backend side, and let everything be done on the front end.
Yeah, I think Google Cloud does the same, like filtering logs. It will just show like user specific time zones, and that can be changed, and
that will be changed in Fire. Yeah.
And sending single time format, and front end is processing it.
Yeah, yeah. That's a great way to design systems. See, these are really small decisions, but they make a lot of performance impact on your system. Like if you have stored time zone aware strings on your database, our database performance obviously takes a hit. So these are very, very small decisions, but actually makes a massive impact. Okay. Stuff to read over here, which you can go ahead and Google it, about database redundancy on standby, one-to-one redundancy, end-to-end redundancy. Not really important one, but it is good to know. Then storage redundancy, RAID, which if you are a CS student, you would have studied in your database course. Geolocation-based redundancy and data center-based redundancy. This is something that you can Google and read about. Okay? How to keep your database, or how to add redundancy into your system, and how to have standbys, or how to have your active failover and all. We will cover a few things in the future, but it is good stuff to read about. So, can we skip break for today? We had some great discussions, but yeah, I really would not want to hog a lot of time there. Okay. So our high-level architecture for now looks like user and a database, because we spent a lot on discussing the database. So we have reached this point. So we have database now. So what do we need to sit in between is who, because your end user does not really talk to your database directly. Your end user talks to your API server. Your API server talks to the database. So this is where your API server acts as that middleman. So your front-end server makes call to your API server. API server has the credentials to connect to the database and basically connects to the database and fires the query and gets the result. So API server here, what it would do is it would talk to the database on behalf of the user, and it will have all the business logic written, like authorization checks, authentication, post-processing, filtering results, every single thing is out there. Right. So the obviously every one of you have written an API server on your own. So this is where your REST API designing comes into the part. Okay, how should you do the REST API designing of your system? So if you're talking in terms of REST, or if you're building microservices based communication, you can go for gRPC or raw TCP based, but it's a protocol that you can choose. Right. Then another requirement that we had to discuss was search box. So to build an efficient search on top of our blog, what we use a specialized database, which is optimized for text searches. So we might not choose to use MySQL or a SQL based database to do it. What we choose is an Elasticsearch. So you'd have API server, you have a database. So all of your database all of your blog reads and writes go to the database, and the search queries that you fire gets connected to another database, which is Elasticsearch. Right. So Elasticsearch, what you have is you'd store all the data in a certain format, which makes it efficient to be, for actually fuzzy searching. Right. So then it is your job to every update that comes to your blog is written at two places, one in database, another in Elasticsearch. So then you'd have to keep data in sync. That is different problem, but you'd have to use specialized database to do that. If you use a database like MySQL to do string matching, your MySQL server would cry. It would sit in the corner and cry. So it is not meant to solve that use case, but Elasticsearch stores those kind of data really efficiently. So using the right set of tool to solve the right set of problem is important. Yeah, Vikas?
Yeah, so I was asking Arpit, like when you were talking about the Elasticsearch database. So I had worked in this Elastic in my project. So I only know that when we are working on fuzzy search, dummy search. So I think that it's working through like matching the text, right? For example, we are searching the text, so it will return all those sentences which belongs to that particular text. So how does it work? Like how the data are being stored in Elasticsearch?
Week 7, information retrieval systems. We will go into internals of search system. I'll talk about Elasticsearch for storage systems.
Yeah. Thank you.
Yeah, Umang?
Yeah. So on that replication part where you discuss, like you'll have to maintain some set of
something that keeps data in sync in between these two.
So in that context, I just wanted to ask, like many a times we see on search bars that the actual content is present, but that does not reverts back with the relevant results. So is that due to the sync problem or something else?
It could be. It is totally dependent on the design. It could be sync where, let's say you update something. Let's say a title of the blog got updated, and the changes are yet to move to Elasticsearch because all the search queries are going where? To Elasticsearch. And if this updated title is not updated in the Elasticsearch data, it is still doing search on the old title.
And also,
so then it would give you the result based on the data that it has, because for Elasticsearch, that is the data that it is playing with. It has no idea what is the other database doing.
Got it. And basically, there would be a different API which would be acting for the search, querying the Elasticsearch database.
Yeah.
Okay. Got it.
Yeah, Kaustav?
So the sync problem. So like does SQL have support to kind of push data into Elasticsearch as well, or some third component has to take care of it?
Because the format of Elasticsearch is very different from your SQL storages, because you might want to structure the data which is optimal for making it searchable using Elasticsearch. Right. So for example, the way you would be storing data in SQL is how we have designed the tables, right? But when you're storing it in Elasticsearch, it could be something like you would have the entire data denormalized. Let's say title, you have tags, which is not IDs, but the actual strings, because what you perform search on is strings, right? On text. So you would want to denormalize the data and store it. So this is very specific to the business. It is very specific to the product, right? So it would be a different job. There would be a different service that takes care of this, where all the updates flow in, and then it pushes, and then it basically transforms it into a certain format and stores it in Elasticsearch, making it optimal for Elasticsearch to search on it.
Yep.
Right. But on the other hand, so updates that come into the API will flow into two directions. So those kind of architecture we'll be discussing maybe tomorrow or the next week on how would we design such systems. Right?
Perfect. Thank you.
Yeah, Rahul.
So what's the purpose of storing in two places? Why can't we just use Elasticsearch as a storage item?
Great question. So why do it? So for this use case, this is a block. For this, we can store everything in Elasticsearch. There is no problem in that, right? But then you are making that choice that you are choosing to use a JSON based or a document based NoSQL storage to store the blocks, right? This is okay for a blog use case. But for certain use case where you can't use, like for example, treat payment systems. You would not want to build payment systems on top of the NoSQL database because it does not guarantee ACID properties, right? For that, you would use SQL-based storage, or you would use ACID compliant databases like MySQL. But you would still have to give search available. For example, searching by customer name. Like let's say you are building a payment system. You are an e-commerce company. You have a payment system. And what you need is you want to provide search on top of all the customers that you have had. For example, I'm running this cohort and I am accepting payments. That payment is sitting on my database. My database has to be ACID compliant, but I also want to search on all the users who have enrolled into the course. Right. That fuzzy query is efficient for Elasticsearch, but I cannot leave my SQL. I cannot leave my ACID compliant MySQL database. Right. That is where I need specialized system. One system which is specialized to handle payment, another system which is specialized to have search. Right. For blog use case, I could have used Elasticsearch. There is no problem in that. Right. But it depends on a certain use case. So just extend this thing to a different use case. You understand? Yeah. Yeah. I think it was Rahul whom I answered. Next is Rajendra sir. Yeah.
Yeah, so kind of related to what Rahul said. So if you look at this problem where the writer is going to be only one who's going to be adding to the blog database.
And directly use Elasticsearch.
Yeah, and then so we have like write ones, but being read by multiple people, would that influence the design in any way?
Yes, that does influence the design in a lot of ways. So let's say if we are just restricting a system to one user system, and which is basically, as you rightly said, which is write once and read many a times, you can choose to use Elasticsearch and skip relational databases altogether and cache a lot of data. Right? If you cache it, your read becomes much more efficient. Right? If you're designing a very teeny tiny system which is as simple as a blog, you can skip MySQL altogether and just use Elasticsearch to store all the data. There is no problem in that because anyway you would have to have search functionality. So why not just use Elasticsearch for all of the use cases? That is something that we all do anyway. So your design, and as you rightly said, all of the design decisions happen with such critical questions like, why can't I just use Elasticsearch? Because my system requirement is just single user, write once, read many times. So why can't I use this database, right? So again, when we started with our database design, I said we would model it with respect to relational world because that's the most common way to do it. But you can anyway denormalize the data and store it in a non-relational database. Right? But yeah, obviously, all of our design choices would be dependent on such things. Okay. Now, if you would want to make things faster, because as now we were discussing, like it is write once and read many times while use case, which means there would be 1 million concurrent users to read from. So this is where caching comes into the picture. So you have a disk-based database on which every read, every get would be translated into a disk IO, which is very costly. What's faster than a disk? It's in memory, right? It's a cache because it does not really have to do a disk IO for that. It has all the data loaded in memory and it can just retrieve that data and send it back. Right, so caches makes things very fast, but they are very expensive, right? So what caches do is caches actually exploits spatial and temporal closeness of the data, right? So it uses the spatial and temporal locality of reference, like how close these two objects are with respect to storage and with respect to time. Depending on that, you can optimize. Basically, you can optimize your read performance. Not and in some cases write performance as well. So caches exist at all the levels in the architecture. At every level that you can think of, now there will be you can add caching to that level, right? I'll give you a very small exercise to do. Spend some time tonight and think about all possible places where you can apply caches. All possible in this blog application, in this very blog application. Think of, we'll be discussing 2 places, but think of all the possible places where you can apply caching. Right, that is something that you would have to think it tonight, and we will be discussing it tomorrow. Right, so caches exist in all the all this thing. Then we have cache hits and cache misses. Cache misses are very costly. Cache hits, we try to maximize the number of times our requests go to caches because it is faster, and then we try to minimize the number of cache misses that happens. Caches helps us reduce what is expensive. So the things that are expensive, caches will help us optimize that. So what is expensive then in-memory reads? It is disk IO and network IO. So caches helps us reduce disk IO and network IO. That's where your cache would come in very handy. So if your request first goes to cache, if your cache has the data and it serves it, you are saving the disk IO part, right? You are saving your call going to the database which performs the disk IO, right? You can also use cache to save a network call. That, let's say if your user already has the data, why to make a network call to that, right? So application server cache was something that is underrated. You can have a request layer caching. This is just something, these are just hints. There are 5-6 different ways to do it. Skim through it. We will have a very small discussion tomorrow about this as well. So application server cache is about your API server caching some data. This is very optimal. This is similar to delegation. This is another underrated way to optimize things. Your application server can also cache data, like your API request server can cache it. You can have a central cache like Redis Memcached. You can have a distributed cache, which is like your central distributed cache, which is like your multiple Redis node connected in a network, and which basically stores data in a sharded way, right? So you have central and distributed cache system. So there are multiple ways to architect your cache layer as well. So do you typically go for a distributed cache when your single cache server is not able to handle the traffic and you want sharding there? You would have a central cache in most cases, and application server cache is something that is a very underrated way to scale this. Yeah, Piyush.
Okay, so in the previous slide, right, when you say that there are different ways to store the cache. So what up for central cache, it is as you have mentioned that we can use Redis and Memcache. What about the other 2 options?
Think about it. थोड़ा सा सोच लेना, कल करते हैं discuss इसको, मतलब क्या हो सकता है, right? So within the application server cache, think about it. How can you leverage? So it's basically request layer cache where caching happens on your API server. It is not happening on Redis. It is happening on API server, and see how it can benefit your performance. Okay. Your central and distributed cache would come in handy when your single cache node is not able to handle the load, and that's where you need a fleet of clusters. It's just about scaling your central cache. It's just about scaling your central cache into multiple cache clusters.
Got it. So I think Redis offers this service as well.
It offers. Yes. Yeah, Anshul.
Yeah, so you talked about application server. Can you go back to last slide? Yeah, so you talked about application server cache. By that, do you mean it is caching the response for an API?
Why not? You can do that.
For that, in Redis, you have to store string, like key can be string.
Instead of storing it on Redis, you can store it on the API server itself.
Okay, got it.
Think about it. It's not trivial. Think about it. How can you do that? Because this is the exercise that I always give to every single cohort. It's really fun thing. Think about all the possible, right from database to your CDN, which we'll be discussing now. All the places where you can cache something, because obviously you get a ton of benefits after caching. Think about all possible places where you can cache. Guys, just give me 2 minutes. Once I cover CDN, then I'll take questions. Just ye wala part ho jaye. Okay. Just keep your hands raised. Otherwise, I'll forget. Final layer of caching is CDN level cache, right? Wherein now you had central cache, you had distributed cache. caching it at CDN level. What CDN does is CDN pay, when you cache something, it gets cached across geography. So if your website is hosted in Mumbai and someone from the US is accessing your thing, that request should not flow to Mumbai server and get served. Let's say your images, like mostly static data is cached on CDN level. There are API responses which you can also cache on the CDN level. But for this thing, let's just stick to images and then we'll extend it to API. So let's say if you're serving static data like images, and since images is like, let's say 5 MB, it's basically 5 MB big. If for every request for your US customer, if it is flying to Mumbai, if the request is coming to Mumbai and going back, so basically such a massive time it would take just to transfer, and obviously the amount of data being transferred is also big, which is 5 MB. Your API would work very slow for the US customer versus for customer sitting in India, right? If you would want to assume, let's say you are expanding your product to two geography, India and US, and then what you can do it is you can have a separate CDN. You can put your data into a CDN, which has one of its servers set up in US, right? So first request will go to India, it will cache it on the CDN. Future request will just go to that CDN and get the data. So CDNs are typically caches. They are basically kind of geographically close caches, which helps which helps application to load faster for a certain geography, right? So Akamai, Cloudflare, these CDNs are great examples for that. You can cache images, static data, even API responses you can cache them, right? And caches sits next to databases, and okay, you can skip that. So there are other honorable mentions like disk caches, CPU caches, GPU caches. These are just hints for you to think about where else you can cache the system. So do spend some time, do a Google search, do research about it, but think about it through, where all the places where you can cache the data. Okay, I'll just take few questions. Yeah, Srisha.
Yeah, why not just use e-tags for this cache?
E-tags as in? That Route 53 setting, on the domain name level.
Yeah.
Can do that.
Yeah. So like when you make a request, you get an e-tag back, right? And you can send the e-tag to the next request, and if there's any change only, it will make a request to the API, something like that.
You can do that. That's another optimization. I'm not saying no to anything, and basically this is not just specific to blog. This is in general, right? So you can obviously have those things.
So what might be the difference? Because I am not very aware of the difference. Possibly, like, could you touch on that? What might be the difference between Redis cache or Memcache, server-based cache versus an e-tag cache?
E-tag would typically cache it on what goes out of your request, out of your servers, right? Basically, whatever is going through, e-tag would help you minimize your cache misses. That's all it do, right? Because when you are just comparing that, if it is changed, then go to this thing. You can typically leverage it to see. It's like hash, right? You can leverage it to see if something changed, then do that. But I've used it at two places, not really very extensively. So let me read up on it tonight, and obviously you can obviously shed some light on that. But I have very extensively used other Jerbos, the caches like this, Redis Memcache and all.
I have used e-tags before, but I do not know the difference between these two. That's the thing. That's why I asked. I have no clue.
I have an understanding on it. My understanding is, so it will be on the browser end. Browser will have a cache which is there. I mean, it has some data. So whenever your browser requests the server to check, sends a request to check if this is the e-tag, and it comes up with a response. If it did not change, it will use from the browser itself.
So basically, is that how browser is actually caching the images and all locally?
Yes.
Okay. But then in that case, it would anyway have to go and make that call to get the image.
Yeah. That was my question.
Yeah. I mean, you can actually set cache policies. I mean, either you can check or you can use the local one with an expiry. I mean, there are options.
So my guess here would be that it might be making a head call, which gets the E tag of that resource, something like that.
Yeah,
And
yeah,
then it
exactly.
would make a actual call that if something changed, then only I'll make. So it would make a cheap call to get a hash of it. And this E tag is nothing but a hash of things. Right. So if
So
that E tag changes.
Even if you expose a head call for that, then your API server should write some logic to, like, in the database.
No, that
if
would be
the
done on
timestamp has
browser side.
changed.
Might be done on the browser side.
But how do you know the
browser by
actual
default makes an
data?
options call, na?
But how do you know the actual data in the DB has changed?
No, it's not DB. It's mostly on the static resource. If you're doing it on the DB, then the application has to handle that. Then the application has to handle that.
So I'll say like the same point overcomes here is, are we trying to over engineer or are we trying to solve the problem place? So, and on the business logic.
There's just one part there with regard to the application use case, that is about the delete option, right? Where you can delete it, but how do you then inform your caches that you have you should not serve those entries, right? So that cache that problem also needs to be handled by the application, right?
Yeah. If you're using pure E tags, let me just think it through still, because how it would work in this case of APIs and all. Not sure it would, but if as Varun said, if it is only with respect to browser side of things, then it has to be around static content. But I do see some 204s being sent by some APIs, which is basically just content not modified or something. So there is a way to do that.
I have used it for a server to server communication, E tags. So yeah, it's not just on browsers.
So then let's so
yeah,
there has to be
we
something
do
which
use
is handled by the application layer, which checks if something changed or not somehow.
We use E tags. So I work in Akamai, and in the CDN we extensively use E tags for caches. It's not just on the browser.
अभी Akamai वाले लोग आ गए तो अभी yeah, please shed some light on that.
Yeah, so I mean, it may be a bit different, but for us, like changing the cache, it's not just the caching part, but also the cache hygiene. Like, how do you know that you're not serving stale content? How do you know? Because for us, something like a live stream, the stream is always constantly getting updated, and all, especially in cases of a write-heavy system. In this case, there is not that case, but it's only delete is the only option that can change the state of a system. So E tags are extensively used to be able to know, especially across different systems. Like in some cases, one CDN may contact, some users use multi-CDNs. And across servers, you need to be able to track the cache entry, and E tags are extensively used to use IMS requests in HTTP to be able to know if something has changed. And IMS requests are generally cheap. So use that to make sure your cache you're not serving out stale entries from your cache.
But then who actually generates these E tags then? Is there application server generating those E tags for the data?
In our case, storage servers generate, all of our storage servers generate. It's like a computer has a hash over the content and
hash
things like
over
that.
the content, exactly.
Yes.
Yeah. And so obviously it has to boil down to that, because somehow it needs to know that data has changed. Like for example, you can have, so if I take example of this blog, you might actually create hash of the body of the blog and also the title of it, basically a massive combined string of the word title and all of those fields, and just create a hash of it, and it would become the E tag, and you can cache it on the basis of E tag. And then if the E tag is changed, then you request for the newer content, otherwise you don't. Making an basically exposing a cheaper options call, which gives you the E tag of the response. And if it is changed, then you make the actual call and get the data, otherwise you don't. Nice. Good to hear from the horse's mouth. Akamai folks. Nice. Thanks.
I'll kind of like to discuss more on it, like off the call, basically, because I worked on storages in Akamai itself. So how exactly is it generated? Was it Sanjeet?
Yeah, Sanjeet.
Okay.
Okay, we could add one more level of caching, which is something like varnish cache, VM-based cache.
VM-based cache, yeah, you can do that. You can cache it at Nginx level. So think about all possible cases, right? Because there are so many options to cache data, no? and it is really hard to think, it is really hard to pick one over other, because you can get a lot of optimizations there. I've used 12 till date, across organizations that I've worked for. I've found every organization I join, I find a new way to cache things. So it turns out that because everyone is trying to hack their way into basically gaining the performance out of the system. So I know about 12 different ways. I would really want to hear from you, because this e-tag is something that I have never, I did not think about it. Yeah, we can actually cache the content using e-tags and by using Varnish also. But I've used an alternative of Varnish to do the caching, but it's really fun.
I have only come across Redis and Apache Kafka and Hazelcast. I mean, how is Redis and Hazelcast different? I mean, Apache Kafka and Hazelcast, those are also caching technologies, right? I mean,
Apache Kafka is not caching. Apache Kafka is a message.
No, it can be used for caching purposes.
No. Apache Kafka cannot be used for caching.
Okay.
No. Apache Kafka is just, it is like a message broker where one message can be read multiple times.
Okay.
Yeah,
there was
Redis
one
and Memcache
use case.
are caches. Hazelcast I've not used. I'm not sure Hazelcast about Hazelcast.
Okay.
Yeah. With respect to caching, what you should be reading about is all the cache eviction policies, and more importantly, how to implement each one of them. Like FIFO, LIFO is straightforward, but LRU, LFU, then random replacement is very simple. But implementing LRU and LFU in order one is an important algorithm that you definitely should be knowing, right? In case you don't find, I've written an article because basically LRU is simple to implement, but LFU is something that I've written an article about, so you can go ahead on my blog and check it out, how to do it in order one. So go ahead and definitely read it, because this is something that might be, if you're preparing for interviews, this is something that could be asked. So caches is something, characteristics. It helps you build very high throughput systems, because reads become not so because reads become inexpensive with respect to time, but cost goes up. There is a problem of cache, which is its volatility, because data loss is possible. If your cache, since cache stores everything in RAM, if server goes down, your cache is going down. Well, basically the data you have stored on cache is lost, right? Because the data is volatile. So that's where you'd have to back it with disk if you are using cache as your primary storage, which no one actually recommends. But if you're doing that, you might want to store something on the disk. So the kind of things you store on the cache, to be ready for the data loss to happen at any time. You typically do not use it for transactional data like payment system, like storing the actual transactional information. You don't use it. It gives you very quick reads and writes. Writes is very important, because since the write is also happening on memory, it is very fast. It is not going to disk anyway. So quick reads and quick writes, but they are super expensive, meant for performance. So you would not want to cache the entire of your backend data, right? I'd make everything lightning fast, because they are expensive. If you have that much of budget, you can do that. But in most realistic cases, you won't be doing that. It helps you reduce disk IO and network IO. We already discussed how we could help us reduce network IO using e-tags, so that if it already has that resource, it would not go and fetch it. Like if the data is not changed, then I would not go and fetch the latest data. I would not fetch the same data again, right? So this is how it helps us save disk IOs and network IOs, right? Three very important types of caching systems. This is an extremely important concept. Understand it well. This will form the building block. This will form the building blocks of our performance on how we are building our systems. Like first is write through cache, where the write goes into your database and your cache at the same time. So whenever a user is let's say with respect to our blog, whenever someone is updating the title of a blog, the title is updated onto your MySQL database and your Redis cache at the same time, right? Write to the DB and write to the cache. If both the write passes, then I say my data is updated. So here I'm acting as my cache as my primary storage as well. So primary as in basically my database and cache both needs to be in real-time sync, right? So any update goes at both the places, right? It gives you very fast retrieval, because your data is consistent, right? So you can read from your cache or you can read from the database, whichever you want to do it. It gives you fault tolerance. So if your cache goes down, your data is there on your database, but database goes down, your data is there on the cache. So it gives you, assuming your cache is not going down. So here what would happen is the writes are actually your API servers are synchronously writing to both. But a disadvantage of this is latency, write latency, because when write is happening, instead of just writing it to the database and returning it, it is writing to the database and writing to the cache, both ways. Also a little higher on the latency side, but in some cases you might want to do writes on both the places, like on the cache and on the database. Yes, Risha?
What would be a policy if in case one of them fail? Okay, let's say you first write it to the database and then the cache write fails. What would be a policy to follow?
It would depend. There is no textbook answer. It depends on how your system would cope up with that. Right. So if your system says that if my database write passed, but my cache write failed, that's okay for me. Your system might say that. Or your system would say that if your database write was successful and your cache failed and your database had to revert. That could be a transactional system. Right. So it depends on what kind of build or what kind of use case you are building on that. Right. So in most cases, you are trying to optimize for your most consistent writes. The data that I'm writing, if it is written in both the places, and I can make a call to my cache and read the data always. So I want real-time sync, as real-time sync between my database and cache as possible. That's why you would use something like this. Yeah, Costo?
Yeah, so in the case of write around cache, won't the API server still have to make a call to the cache to tell it to invalidate the?
Yeah, it would have to do that.
Then we aren't really saving on write costs a lot, right? Because we have small writes, couple KBs. So does it really make that much?
Let me walk through the write around cache first.
Okay,
the thing that we discussed was write through cache, where writes happen on both the places.
Yeah.
Now let's talk about write around cache. So what happens here is we write to the DB, but we do not write to the cache. Okay, we do not write to the cache in that request context. Then there is a sync application that takes this update and slowly populates the cache. It means that we are not incurring the write latency of doing a sequence or doing a transactional write on your cache and your database together, versus what we are doing is we are just setting it to the main place. And then what we are doing is we are either syncing our cache through an asynchronous job or letting the first cache miss to happen and then populating the cache upon that. Okay, so listen here. This is very good for use cases where the newly write data is not immediately read, right? Which means that you can have some latencies, right? So let's say if you have written something and if that is not immediately read, if it is not immediately read, right, from the cache, so then what would happen is you have some time to sync the data through an async job, or you can have a very high first, or you can have a cache miss at first and then populate the cache upon request. Right. So those kind of use cases, you can have a write around cache. Right. So this means that in the first case, what we were doing is every write is also going to the cache, which means we were flooding the cache every time. But here we are not flooding the cache because not every write goes to the cache. Correct. If the data is read, then only it is cached. So we are not populating the cache expecting a write. We are definitely populating the cache when the reads are happening. Right. So recent and the problem with this approach would be the recently written items will have a cache miss upon first read, and then the cache will be populated. Right. So either through, if you're doing with async job, then there would be cache miss until the data is synced. If you're not doing that, you are incurring your first cache miss and then choosing to populate the cache. Right. So these are the pros and cons of write around caches. So when you're building a system about it, think about where you would want to put the cache and what should be your cache population strategy. About eviction strategy, everyone thinks about. But what about cache population strategy? How would you choose to populate the cache? Okay. The third type of thing is my favorite. Write back cache. Write to the cache first and you say IO is done. And then you slowly sync the data into the database. This helps you create really fast systems, really fast, low latency, high throughput, write intensive application, all strong words. Huh? Low latency because all you're doing is writing it to the cache, not writing it to the DB. High throughput systems because you are just writing it into an in-memory thing. And write intensive application because your write latency is very low. You are writing a lot of things. So your write intensive applications will go very fast. But the cons is your data availability is as risk because since you're writing it in the cache, and if your cache goes down, you'll have a data loss. But if you can incur that, using a write back cache is the best way to get performance out of the system. Like just imagine you never have to do any disk IO, never have to do any synchronous disk IO. You would obviously do a backseat dheere se you would put the data in your database, right? But this is a great way to build low latency, high throughput, write intensive application. Because these are the 3 caching strategies that we'll be using a lot during the entire course.
So the applications like Twitter and Instagram where we like and like it'll be a write back cache, right? Probably.
It is write back cache, but not on the central cache, but on the app side. So on the app, it gives you like happened, but then it slowly makes an API call.
Okay, yeah.
Right. It just gives you that immediate feeling that like happened. Right. It just updates the count plus plus. It just makes that call, but then it makes an API call. If it fails, it does a retry and all. It does twice or thrice retry. If you open Instagram app, and you actually monitor the network IO, you will see that when you make a like, and if your request fails, then it does a retry thrice of that same API request. So I was fortunate to see that. So what I did was I actually slowed down my internet using my Chrome browser, and I increased the latency to a very high thing. And I let the Instagram server do a timeout on my request. Once the timeout happened, I saw that it actually retried making that request, and then it retried again. It did 3 times. So this is another way through which you can identify how systems are built. Like just change the network settings of your browser to monitor this to mimic the slowness of your internet and see how those systems are behaving.
Yeah. Okay, great, thanks.
Yeah, Srisha?
Could we do something like this? So let's say you have a high throughput write system, and then instead of writing it to cache directly, we could sort of put it in a queue, and one worker can write it to cache, and sort of
depends on the system you're building. It all depends on the system. So imagine a use case where you can pick this. Just imagine a use case where you would want to have your write to go into a queue, not even into a cache, into a database, but into a queue, and then it syncs into database and cache upon will. Okay. There are systems like this.
That would like eliminate the negative aspects of this write back cache, right? Or
yes, it would. But think about think about a genuine use case to solve this problem. It's not that common to think about it, but if you can think about it, then do share. I have 2 in mind that I'll be covering in week 6. Where would we choose to use a system like this? And your batch is like quite fast. One of the things that I wanted to cover was सबके spoiler are already out. But yeah, it's fun. New challenge for me.
Is that a notification system?
In notification system, you can do that. Where you are writing it here, basically instead of writing it onto a database, you can do that. With respect to CDN, few final touch points on that. On where would you use CDN? It would get the content from the closest available servers instead of hitting the main server. Geographically, closeness is something that could leverage. Obviously, we have folks from Akamai who know it better than me. It helps you increase the speed of your application, reduce the load on your servers, improve the uptime because your content is spread across it. Even if one goes down, other can serve it, and improve security. DDoS, botnet, and whatnot you can use to improve security against DDoS, malicious users, and all of those parts. So typically, when you open GitLab, most of you open GitLab, you see wait for a few minutes. We are checking browsers, checking something that message comes out. It's basically checking for a malicious user and ensuring that it is a genuine request by the CDN where the request is going. So this is a great one. So CDNs are great to delegate security to. You get by default rate limiting. You get fast, you get speed, low load on your servers. You can delegate security to CDN. CDNs are great way to optimize the performance of the system and optimize the response times of the system by that's a better word. Few limitations of it is obviously dirty content served to the user if your cache is not invalidated, because until the cache invalidation happens, it would continue to serve the stale users. So you would have to either explicitly notify your CDNs ki, array, this data is now stale, update the data, or basically invalidate the cache explicitly, or have a TTL set with it. If the TTL is set, then it would automatically evict the entry from the database. And then caching policies and configurations is something that you would have to keep in mind while picking CDN. So you can configure a lot of things on the CDN side. What content could you keep on the CDN? Any content that does not change often is typically how you build, you use a CDN. Like images, videos, live streaming is a great example. APIs, some static API responses that you would want to have, like for example, one API call that gives you configuration of the system to all of your end users. So Dubsmash is a very great example. So Dubsmash, when it launched, it was just 2 or 3 engineers, one gigantic JSON file hosted on S3, served using Amazon CloudFront. That was all their application was. Every time a user uploaded a video, they didn't have a database. Every time user uploaded a video, they used to manually create entry onto manually as in they used to create entries into this JSON file, and it was served using CDN. So every time the app opened, the they actually got the entire JSON file. So think of it like the entire database was downloaded onto the user's device. Obviously, they didn't have much of videos, only 10,000, 50,000 videos were there at that time. So, and it was a read heavy system. So they had this way into this thing because they wanted to quickly test their prototype, and it worked wonders for them. Right. So this is a great way to just test the market before you start building your next big product. Right. So these are hacks that people apply. Yeah, Anshul?
So how does CDN provide authentication? Like as far as I know,
It
it provides.
It doesn't. Well, authentication, it gives you signed URL, but it does not do user authentication with your database.
Yeah. Okay.
So where would cache sit in our architecture? It would virtually sit next to the database, but physically it would be another server which APIs can directly talk to, right? But it can virtually sit right next to your database, right? So your API server can go to the cache. If the entry is not there, it would go to the database, get the data, populate the cache, and serve it back, right? So it is virtually sitting right next to the database, but it is physically sitting as a separate server, which API server is talking. Right? And finally, we are done with database and caching. Long time. Chalo, maza aaya. Any questions? No? Chalo. Yeah, that's all from database and caching side of things. Tomorrow we will cover the other 4 things. Do think about how or where or basically at what places can you cache and how you can cache, right? And not the typical definition of cache. Just understand what caching is. Caching is something that helps us reduce an expensive operation. Okay, think about that. Take this as a guideline. Like think about any expensive thing that you should be minimizing on, and that would act as your cache, right? And basically cache, as I said, might not just be in memory. It could be other places as well. Think about it. Is just a little sneak peek for you to think about. If you already know about it, great. If you don't, do research, find it out. Tomorrow this would be the first thing that we will be discussing. Okay. So, awesome. If there are no questions, then we can conclude.
Here with 2 things.
Yeah.
One is between these systems, right? Database and Elasticsearch, which is that syncs this thing. The second is more of a request. It's about the Instagram likes thing that you were quoting. Can you show us a demo, maybe in the follow-up sessions where network latency?
Network change Chrome में जाके.
Okay.
But
maybe you would like to show.
I did it about 1.5 years back. Okay. So I just need to share कि वो होता है अभी. But तब मैंने किया था. But basically this is a great way to test it. Slow down the network, let the API request file and see what the client does.
Yeah, maybe for the uninitiated ones, so because not all of us are good on the server and network sort of stuff.
Wait, what? I didn't get you on the last part.
So I'm saying ki, basically for the uninitiated ones, because not lot of all of us are good on the database and network side of things. So maybe just want to see
Uninitiated
that.
one is
Like we never know that how to check for that network latency, how does things works in the backend and so on.
Acha, arey, you don't have to do anything on the backend side here, na? On the Chrome, you open the network tab, you can throttle the internet connection. If you're talking about Instagram likes, na?
Okay. Right.
So it's about opening up the browser, opening up the network tab, and in that throttling the network connection. So there you can mimic the network speed. So you can change the network speed. Even though your computer is having a very high network speed, your browser can throttle the network speed. So your browser can mimic a 2G spectrum. Your browser can mimic a 3G one. Like, so you can change the speed. You can change the speed to, let's say, 10 kbps. Right. And then see how the website performs.
Sure. It sounds interesting actually.
Yeah, it is. So answering your first thing, how the data is synced between your main database and Elasticsearch, it could be, again, your API server putting message into a consumer consumed by a system and putting it into database. So this could be a worker that consumes from a queue, let's say an SQS. So every write that happens, it goes to database, updates the cache, and for example, goes to the database, updates the cache, and puts it into this queue. And this queue has a job present whose this queue has a worker in place, and this worker consumes the messages from the queue. And once it consumes the message from the queue, it basically transforms the object into Elasticsearch friendly object, which is optimal for searching, and then stores it in the Elasticsearch. So an asynchronous way to do it. So in this thing, it makes 3 writes upon every read or upon every write. One goes to the database. Let's say if you're using write through cache, then the second write will go to the cache, and the third one will go to this queue, which says that, okay, now this write has happened. Now index this data into my search engine. Something like an ETL jobish. Okay.
Sure.
So I have an area that I'm not sure of the security of CDN. You have touched upon saying that it's a signed URL. Can you explain?
थोड़ा गूगल कर लो ना उसका signed URL we will anyway cover tomorrow. तो उस पे थोड़ा हो ही जाएगा, but थोड़ा सा मतलब I would not, मतलब if I give you answer, no, that would be not fun as much as when you would explore that part, because you would stumble upon few really interesting topics. I can give you answer right now to what happens. Then we have folks from matlab I'm redundant in that case, but everything is figure outable, right? So try to Google something, and if it is and if you still don't understand, then reach out, because then what would happen is you are putting in that effort to understand, and you will definitely stumble upon really interesting things. Right. So asking is simple. It gives you quick answers. It gives you that quick dopamine push, but basically finding it on your own, बहुत मजेदार होता है. I would not really want to rob you from that happiness. That's why. Otherwise, I'll give you answer tomorrow for sure. Okay. I'll just put it here. This is you and goes here. Okay. Chalo. Since there are no questions, so yeah, let's conclude. So आधा घंटा तो extend हो गया. Fine, but yeah, it was fun discussion. We discussed really interesting things. Tomorrow we'll again meet at 4. We'll cover the other 4 part of it, other 4 components of system design, and then we will basically conclude our blog design. And I'll share the feedback link and all of those things in the email and on the Discord channel. If you guys are not on the Discord, private channel on the Discord, do ping me explicitly, because since your username is something that I was unable to figure it out, so I did not add you to that group. So yeah, thanks guys for joining in. I'll see you tomorrow at 4. Thanks guys.
Okay, bye.
Thank you. Bye-bye.
Bye, folks.
Mm.